Dear students, this is your topic, namely electric line of forces or electric field lines. So first of all, what is electric field lines? Electric field line, it is an electric line of forces drawn in a electric field in which unit positive charge move if free to do so. Means it is a imaginary lines which designate the directions of movement of a test charge. So what kind of this? These electric line of forces, they are either generated by a positive or a negative charge or a both. Like that, for a positive charge, they are like that. Their distribution around the positive charge, they are radially outwards, and their strength in this radial outward direction, it is goes on decreasing with respect to distance. Means its value as we move away decrease. For a negative charge, these electric line of forces, they are radially inward. Like that. These arrows show that they are directed toward the negative charge. And here again, their strength toward the negative charge, it is a increasing one. Means their negative value toward the negative charge, it is in increasing order. What in terms of their positive value, it is increasing orders. And these arrows show their magnitudes. So what I should say, these electric line of forces, they are originated by a positive charge and it is terminated at a negative charge. These electric line of forces, they are radially outward for positive charge, and for the negative charge, they are inwards. In actual, what they are a imaginary lines. They are a imaginary line showing the presence of electric field due to a source charge, and their presence is felt because of the movement of a unit positive charge. So what is their properties? Their property is they never intersects. Two electric line of forces, they never intersects each others, and directions of these electric line of forces can be obtained by drawing a tangent on these इलेक्ट्रिक लाइन ऑफ फोर्सेस लाइक दैट. इस तरह से जैसे मान लो ये हमारे पास एक इलेक्ट्रिक लाइन ऑफ फोर्सेस है. अगर हम इस इलेक्ट्रिक लाइन ऑफ फोर्सेस के ऊपर डायरेक्शंस निकालना चाहते हैं, तो जैसे मान लो ये इसके डिफरेंट पॉइंट हैं, तो इन पॉइंट्स के ऊपर जो हम टेंजेंट ड्रॉ करेंगे, दैट विल शो द डायरेक्शंस ऑफ ए, electric field strength, and these two electric line of forces, they never intersect. Suppose this is our first electric line of forces, this is our second electric line of forces. If I draw again the directions at a different point on this second line, then their direction is this one. At a different point. And here we notice that at this point, which is on the first electric line, let it to be a P, the directions in which the unit positive charge is moving, it is the two one. What at a time, a given unit positive charge, it never move in two different directions. So that is why it is assumed that these two electric line of forces, they never intersect. They never intersect. And if we have a two equal and opposite positive charge, let's say suppose this is positive, this is a negative charge, then electric line of forces due to this equal and opposite positive charge, this seems to be exerting a longitudinal tension in between them, in between the line of joining, because their pattern here it is like that. So here these electric line of forces which are because of positive and negative charge, this seems to be exerting a longitudinal tensions along its radial lines, and at the center of these two positive and negative charge there is a uniform electric field, and this uniform electric field seems to have a longitudinal tension. What if we have a unequal charges? This is unequal charges or like charges, either positive or a negative ones. Then their electric line of forces along their radial line, this seems to be exerting a lateral pressure like that. So what we notice here, we notice that at its along its radial lines, at this along this radial line, this one dotted line shows the radial lines, there is a lateral pressures along the plane which is in between them. So this is what? This is some sort of a lateral pressure. So it is property. Our next one topic is electric dipoles. What is electric dipole? When two equal and opposite charges separated by some distance, then they constitute a electric dipole. Suppose this is our positive charge, this is our negative charge, minus q plus q. They are separated by this distance. Let this distance is 2a. Then they constitute a electric dipole. Electric dipole. So how we can define it? We should say it like that. Two equal and opposite charge separated by some distance is known as a electric dipole. Electric dipole moment. Electric dipole moment. Electric dipole moment, we denote this physical quantity with the words P. And this electric dipole moment, it can be, it is a vector quantity. It can be written as this one, P as equal to Q into 2A. As it is a vector quantity, so it should be designated with the words, with the symbol arrow on the top of it. So is another one definition is also that electric dipole moment may be defined as equal to the product of magnitude of either charge and distance in between two charge particle. Here distance in between two charge particle is taken as a dipole length. Dipole length. So directions of electric dipole moment, it is from negative to positive charge. This is minus q, this is plus q, and directions of electric dipole moment, it is from negative to positive charge, and its magnitude can be taken as equal to q into 2a. 2a is the distance in between them. Our next one topic is to find out electric field strength due to a short electric dipole along its axial lines. So what is axial lines? The line joining this, suppose this is a negative charge, this is a plus q charge. They are separated by a distance 2a. This is also known as dipole length. Axial line, the line joining the center of these two equal and opposite charges, is known as its axial lines, which is along its dipole length. And along this axial line, we are interested to find out electric field strength. That one is the E. This is axial line. Let P is the point on these axial lines at a distance small r from the center of this, let this is a center C. This point is A, this point is B. At this point P, we are interested to find out electric field strength. So what is electric field strength at this point P? Electric field strength we can find out by using the electric field due to plus and minus q charge. So at this point P, electric field due to a positive charge, I designated with the words EB, its direction is radial outwards, and electric field strength due to a negative charge, at this point P, it is directed toward negative charge. That one is EA. Magnitude of both these two, EB, it is equal to Q 4 pi epsilon naught into the distance CP square. Here this distance CP square, it is equal to, look here, this distance is not CP but BP square, because we are taking here positive charge. So at BP it is equal to R minus A. This is a BP. R minus A. So its value can be taken as equal to Q 4 pi epsilon naught R minus A whole square. Let this equation first. Due to the negative charge, electric field at point P, I designated with the word EA. Its value, it is equal to Q 4 pi epsilon naught into distance AP square. Here this AP square, this is AP square. It is equal to R plus A. So I should write here Q 4 pi epsilon naught R plus A whole square. This is equation 2. So total electric field at this point P due to both charges is the resultant of both. Their resultant, it is directed toward the electric field EB. So here E is their resultant electric field. It is directed in the direction of EB, and it is equal to E, which is equal to EA plus EB. EA plus EB, what EB, and if I write their value, since EA has a direction opposite to it, so I should write here minus. So when we put the value of both in this equation, then q upon 4 pi epsilon naught, it is taken as common, and EB has value 1 upon r minus a whole square minus 1 upon r plus a whole square. Now we can solve this factor which is taken in the bracket like that by taking LCM, and its value can be rewritten as this one. This is r is LCM is r square minus a square. We are using here trigonometric, not trigonometric, algebraic formula, a plus b into a minus b ka whole square, and this is it is equal to r plus a whole square minus r minus a whole square. So when we solve this above term, then its further value can be written as equal to q. So first of all, we should solve it, and its value in this bay is equal to q r square plus a square. In both terms, it will get cancelled. Only the remaining factor here is 2ra in first, and also plus 2ra in second one factors. So 2ra plus 2ra, it is equal to 4ra divided by 4 pi epsilon naught r square minus a square whole square. So we should write this factor as equal to this one, q into 2a 2a into 2r 2r also upon 4 pi epsilon naught r square minus a square whole square, and q into 2a, we know it is equal to p into 2r upon 4 pi epsilon naught r square minus a square whole square. So in term of vector, we should write it as this one also. So this is the strength of electric field at this point P due to a short electric dipoles. And if we assume here that if this point P lie very close to very close to the point B, then, or what we can say, if point P lie very close, point P lie very close, or if R is very small as compared to dipole length, then its value, then here R can be neglected. R can be neglected, and its value at the centers, it is taken as equal to 0. But in another way, imply E is 0. But in another way, if R is very large as compared to its dipole length, then A can be neglected. So when we neglect A in this equation, then E, it is equal to P to R. Here A can be neglected, 4 pi epsilon naught R4. So this R, it is cancelled with this. So our net value, it is equal to 2p 4 pi epsilon naught RQ. This is what? This is the expression we obtain in this case for a electric dipole along its axial lines.